Here I have my radio that I'm designing for the Homebrew Challenge 3 blocked out on the workbench. You can see kind of the transistor lineup and the switch configuration. So hopefully we'll get this radio done in time to complete the contest. Alright, here's my low-pass filter board that will be placed right after the transmit power amplifier and LNA. These two relays select the 6-meter or 10-meter low pass, and this one selects between transmit PA and receiver LNA. Alright, here's the bandpass filter and front-end mixer assembly complete. Okay, here we have my front-end preamp and half of the pre-selector assembly. Try to zoom in or the camera closer. There is the tiny PRF 949 low noise NPN transistor. This is my ERA2 mimic follower. The total gain stage here is about 25 dB. And shown up here, the spectrum analyzer is a really nice strong signal at 52 megahertz, and we drop it back down to 10 meters, and there we are. Same nice gain characteristic. It's a really nice LNA assembly. Alright, here's my BFO and product detector assembly. So shown here is the BFO circuit followed by an amplifier that gets the drive up to about 18 dBm. There's my mixer, and right now I have 8 volts and a IF input and the spectrum analyzer output connected to it. And as you can see, as I vary the IF input, it is multiplied, and there's the result. So this module is now working. Here's my IF amplifier. It's now complete. I'll zoom in a little bit. I used a bigger circuit board here because I wanted to leave room to add an additional crystal filter on the output. So here is the receive IF input, and inside, right down here, you can't see it, but there's a little wideband op-amp, current feedback op-amp with 25 or so decibels of gain, followed by 2 crystal filters, CW and single sideband, and there are relays to select between which filter. And this is part of the TR switching. This whole IF amp is bidirectional. The output of this goes into a Motorola MC1350P IF amp, which is a very nice high gain amplifier. And the total gain of the whole thing, including the losses of the filters, is about 60 decibels. So that should be sufficient for sideband reception and transmission. So when you transmit, when you receive, the signal flows this way. When you transmit, this amp is bypassed, and you actually go through this one and through your filter, then out. So you don't use this guy during transmit. So that's the IF amp. Okay, I've got this this VFO kit from K5BCO and K5JHF. Works quite well, and we'll be using this as the LO and the radio. Here we go. We've got the radio all laid out on a piece of wood here, and we're listening to some DX right now. So this is what it looks like on the breadboard. There's the front end filters, low-pass filters, bandpass filters, LNA, bandpass filters after the LNA, the LO display, the single sideband CW filter, bidirectional IF amp. All of this is bidirectional. And then there's the BFO and the product detector. Okay, here's my radio today. You can see that I have the audio, transmit and receive audio complete. And I built this little panel here for the bench, so you have your band select, PTT, CW sideband, RF gain, AF gain, transmit audio, and I got this transmit mic hooked up. So, if we watch the spectrum analyzer here, see me transmit N8ZRY, November 8 Zulu, Radio Yankee, test, test, November 8 Zulu, Radio Yankee. Alright, so the receiver and the exciter are now working. So what we have to do next is we got to hook up a driver and power amplifier that need to go right here. Alright, so I now have the pre-driver complete for this for my ARRL Homebrew Challenge 3 radio. So here it is. This board receives minus 10 dBm in from the front end mixer, okay, and that comes in right here. Now right there is actually a N8ZRY wideband current feedback op amp with a little configured so I can adjust the gain with a screwdriver in this potentiometer here. Okay, so this will bring the input from minus 10 dBm up to plus 10. And that's fed out here to a it's a Mitsubishi RD06HVF1 N-channel MOSFET, okay, RF power MOSFET, which has a 47 ohm shunt input resistor on it. So this guy will bring it up to maybe a watt or so, and then or maybe actually about half watt, and then the output of this via this transformer here goes to the second of the same transistors, and this one is terminated with a 10 ohm input impedance, and this guy will kick out 5 watts or a little bit more than 5 watts. So with minus 10 dBm in here, out comes a stable 5 watts here. So this circuit is actually on right now, and I've already checked it with my spectrum analyzer, and the signal purity is quite good. Now let's see here. So here's my SIGGEN, and what we're going to do is we're going to crank up the output to minus 10 dBm, and then we'll watch how much power we're getting out here. So this isn't the most accurate watt meter, but it's pretty close. So, and here's minus 10. So it says about 6 watts with minus 10 dBm input. That's perfect. If we crank up to 0 dBm input, we're getting almost 15 watts out of this pre-driver. So this pre-driver is probably good enough to drive a nice 100-watt amplifier. Now I'll show you what we have hooked up to monitor this thing. So this is the current. We're at 900 milliamps at 14 volts. Here is this is the temperature of the last the final of the driver itself. So again, we have pre-driver, op amp, set, driver, set. So yeah, it's pretty sweet. So the next steps here will be to implement a PA, a power amplifier off of this, and I think I might. I'm trying to debate whether or not to use a 30-watt transistor or a 100-watt. And with this driver, I could probably drive 100-watt, no problem. So let's see what happens next. Okay, here we have the audio board complete, which is shown right here. This is the receive audio and the transmit audio, and we have a mic connected to it here. It's also the side tone oscillator. If we push this button, resembling the key, you can hear that. And then furthermore, I built this little carrier oscillator right here. So when you key down the CW key, it feeds a little carrier tone into the IF signal chain when it's transmitting. So the next step will be to vet out the automatic gain control circuit. You can see the AGC circuit right here. It's just based around this LM324 op amp, but we need to adjust and troubleshoot it. Alright, I'm going to demo the RF gain control. It's currently working. Here's the signal meter, RF gain control circuit right here. As we tune across a test signal from my SIGGEN over here, you can watch it. There's the AGC kicking in. If we let off the AGC, go to full scale. No AGC, AGC on. Alright, pretty cool. Okay, I'm going to demo the power amplifier here. In this shielded enclosure we have the driver, and here is the power amplifier itself. It's quite small. It's using a NXP BLF 647, which is good up to 150 watts. We're driving it with 10, and right now I'm getting about 110 watts out of it. So with minus 10 dBm input drive. So we'll turn on the 28. So here's our drive, our power meter, and we're at minus 10. There we are, 110 watts, minus 10 dBm drive.